this recording. My name is Nyalungu FI. I will be presenting to you today Industrial Electronics N4. The chapter that we'll be dealing with is diode application. So we'll be doing diode application together. Yeah. So here, let's just assume we have on the primary side, we apply, for example, your VAC. We say this is equal to maybe 20 volts, right? VAC is 20 volts. So this is the secondary side. So you are also maybe given the 10s ratio. They can say this is 10 is to 1. They give you something like that. And they say to you, calculate the secondary voltage, right? So the secondary voltage is the voltage that you are going to measure across secondary windings. That is the secondary voltage. The value that is stepped down. So you are stepping down 20 into a certain value. It could be 5, for example, or it could be 10 because you are using the step down transformer, right? So the primary voltage can be measured across the primary windings. So the secondary voltage can be measured across the secondary windings. So this is actually the voltage that you supply anything that you see, the diode and the load, the secondary windings, right? So before we perform calculations, we can now calculate the secondary windings if we're given information like this. But before that, I just want us to look at this diode, right, as it operates. We know that it can operate. When it's connected in a forward biased mode, right? That's where it operates as a conductor. When it's connected in a reverse biased mode, it operates as an insulator. We say it does not conduct, right? So now let's look at this circuit. This is a half-wave rectifier, right? So you are converting AC quantity into DC quantity, right? So meaning that now this DC quantity you would have cancelled now only one direction. As you know that AC current is a current that changes direction, but DC current is one directional. It flows in one direction. It doesn't change direction. So here we are talking about the AC that you are going to apply. We are going to consider both directions, right? So if we are going to have, let's say for example, the input signal. We have an input signal, for example, with a sine wave. This is your input signal, right? We know this is the positive half wave. We have the negative half wave. So this is what you have. So this is the input, right? This is your input. So this is your input. This is your AC. This is what you want to do. What? This is what you want to convert, right? This is what you want to convert. Right. What we're going to do is that you are going to step down. You are going to step down this value. If it's 12 volts, you are going to step it down, and then now you have a secondary voltage. The voltage that is taken from the secondary winding is then supplied to whatever is connected on the secondary side. Right. So you will then see that it is always very, very important for you to calculate the secondary voltage because your rectifier is connected on the secondary side, right? So we use the primary voltage to just, we use the transformer to just step down the primary voltage, right? Step down the primary voltage, and then we can now then supply the secondary voltage to whatever it is that is connected on the secondary side. In this case, we are going to supply the voltage to our rectifier and the load. So you can see that the voltage that you apply here is AC. Now the secondary voltage before the diode, it's still AC, right? Because we are going to use that diode, right, as our rectifier to convert from AC to DC. So now you will then see that any voltage that will be measured after the diode, like for example, the voltage across the load will be VDC. What you are going to measure here will be VDC. But the voltage that is supplied by the secondary windings, it's AC, right? It's the one that must be converted, right? But remember, what you are going to convert here, I believe you know guys about RMS values and maximum values or peak values, maximum or peak, right? So if you are given values like this here, you are then required to start by calculating the secondary voltage. Now, when you have the secondary voltage, right, if they did not specify, they did not say anything, they just gave you values like 20 and 10 is to 1, and then you apply that equation, the transformer ratio formula, to calculate the secondary voltage, right? You assume that what you have calculated is an RMS value, right? But what you are going to supply to your rectifier, which is the diode, it has to be the maximum value, right? The maximum value of the secondary voltage. The maximum value of the secondary voltage. That's what you are going to apply to the diode, right? So let's assume AC. Let's assume this is AC input to our rectifier. Let's not talk much about the transformer because the transformer is only there to step down, right? Let's just say this is the value that is now reduced from 20 because we're using a step down transformer, right? This is the value that is now reduced from 20. We can give it a magnitude and say maybe this is now, for example, 10 volts, right? You got 10 volts. I don't know if you're going to use these values to calculate, right? So let's just assume our secondary voltage is 10 volts, right? Now, we are going to take this 10 volts on the secondary side, these 10 volts as what? As RMS. So this will be V RMS. They did not specify anything, they just gave you values 10 is to 1 and 20. And we are using this 20 and 10 is to 1, which are the 10's ratio, to calculate the secondary voltage. You get 10, right? This 10 is also an RMS value. So you must make it a maximum, right? So that's what we are going to convert. So let's assume this is a wave that is supplied. Let's assume this is the wave that's applied on the input of the diode, right? That is applied there on the input, or that is supplied to the diode, the secondary voltage. I just want us to know how to draw the input wave and the output wave. Right, so if this is AC, you want to convert AC into DC. Obviously, the output is not expected to have both directions. So we are going to only have one direction. Remember, we are converting from AC to DC. So this is actually AC, but on the other side, we expect what? DC. So what is it that is going to do the job for us? It's our diode, the rectifier. Right. So now, if we are going to say this is A and then this is B, as you can see, A and B, right? And we say now here we have a plus, then we have a minus, right? And then we know the diode, that is the positive terminal of the diode, and that is the negative terminal of the same diode. So that's what we have, right? So if we check here, during the positive half circle, we are now trying to find out how do you draw the output if you are given the input as AC. How do you draw the DC output, right? Now, during the positive half circle, where A, right, is positive and B is negative, this diode is connected in a forward biased mode during the positive half circle, where A is positive, B is negative. The diode D is connected in a forward biased mode. Therefore, it conducts. Right? So, because it conducts during the positive half circle, it will then generate a half wave on the positive. Right? So, this is what's going to happen during the positive half circle. We are going to have a half wave, right? Generated by D. Right? This is during the positive half circle. Good. Let's continue. Now, during the negative half circle, we now change the terminals. We make A to be negative and we make B to be positive. Now, this is the negative half circle. Now, during the negative half circle, let's check what is it that happens during the negative half circle. During the negative half circle, as you can see, the diode is connected in a reverse bias mode. Right, this is what we talked about. Negative to positive, positive to negative. This is reverse biasing. The diode operates as an insulator. There you have the diode operating as a conductor. So during the negative half circle, where A is negative and then B is positive, this diode operates as an insulator. Right? So it will then block the flow of current. In other words, the diode during the negative half circle, where A is negative and B is positive, the diode does not conduct. We will expect a negative wave to be generated, right? But it does not conduct. So there is no negative wave that is generated for half wave, so the current is zero. Therefore, we're going to move here on the reference line, right? So we change again, we say, during the positive half circle, what happens? We know that this diode is now connected in the forward bias mode again. So, forward bias mode, positive to positive, negative to negative. The diode conducts again during the positive half circle. Therefore, it will generate another half wave. This is a half wave generated by D. So, you see, so this is the input, this is the output. So for a half wave, if you are given an input that looks like this, you just have to clip out the negative half waves. The negative half wave must be clipped off. Can you see? So it doesn't matter. I can continue here and make more circles. Can you see that? So you just look at the input and then you remove the negative half waves. That will be your output. This is only applicable if you are dealing with a half wave. Let's now move on to a full wave. Now, a full wave uses two diodes. You can see you have D1 and D2, right? If I can say this is A and this is B, right? I say this terminal is now positive, this is negative. This is the positive terminal of the diode, this is the negative terminal of the same diode, right? We know this is the positive terminal of this diode, and then this is the negative terminal of D2, right? So during the positive half circle, before we get we'll talk about that, let me just draw the input. Let's have the input. Let's have the same input, you know. So this is plus, this is minus. So these are the direction, the positive and the negative direction. So how can you draw the output here? Let's try it. We want the output, the DC output for a full wave, right? The DC output for a full wave. Remember what we said? We said if you are using a half wave and you are given this as the input, you just have to remove the negative half waves, right? You leave only the positive half wave. That will be your output, right? Let's now look at this one here. Now, during the positive half circle, let's look at this diode, D1. You have plus there, you have minus there, right? If these terminals, you have a plus there, you have a minus here. You have connected the plus to the plus, right? Remember, in this case, these windings are the ones that are going to supply the voltage to the diode. So you see, the positive terminal of this supply is connected to the positive terminal of the anode of the diode, right? And then the negative terminal is connected to the negative terminal of the supply. So you can see D1 is now connected in the forward bias mode. Therefore, it conducts. But when we move on to D2, let's look at D2 carefully. D2, you have negative that side, as you can see, you have a negative there. You also have a positive. Let's check our supply. So you have negative connected to positive. Can you see there? And then you have negative there connected to positive. So D2, during the positive half circle, where A is positive with respect to B, D2 is connected in a reverse bias mode. D1 is connected in a forward bias mode. Therefore, D1 conducts. D2 does not conduct. It operates as an insulator. Right. So during the positive half circle, the only diode that will conduct is D1. Right. During the positive half circle. So we will then expect to have a positive half wave generated on the positive. Right. That will be the wave generated by D1. Because now the current flows through D1. So we have the wave for D1 during the positive half circle where A is positive and B is negative. So we can say this is D1. Right. Now during the negative half circle, now let's check the terminals. During the negative half circle, let's make A to be negative and then B to be positive during the negative half circle. So let's have that. So we have that one is negative and that one is positive. So during the negative half circle, you can see that now you have connected. This one is negative, you connect it on the positive terminal of the diode. This one is negative, it is now connected to the positive terminal of this supply. So you can see that during the negative half circle, the diode D1 is connected in a reverse bias mode. It operates as an insulator. It does not conduct. It blocks the flow of current. But D2, let's check during the negative half circle. D2, let's check. You have a plus there connected to a plus, and you have a minus connected to a minus. So this diode D2 is connected in a forward bias mode. It will then conduct. It will allow current to pass through because it is connected in a forward bias mode. But now you see this D2. It operates during the negative half circle. It operates during the negative half circle. But you will expect now to have a negative half wave on the negative, a negative half wave, right? Generated by D2 because it operates during the negative half circle. But what will happen is that instead of having this half wave on the negative, this half wave will then be inverted for a full wave. Instead of having it here on the negative, it goes to the positive. So we have what? D2. Right? So for D1, for D2. Right? Instead of having it on the negative, it flips to the positive. Or it is inverted. Can you see that? From negative to positive. Right? So you continue during the positive half circle where A is positive and then B is negative. What happens? D1 conducts. D2 operates as an insulator. Therefore, D1 will conduct another half wave. So it's D1. You keep on changing. During the negative half circle, D2 conducts. D1 is operating as an insulator. Then, during the negative half circle, the D2 is going to conduct another half wave, but it will be on the positive. right? So this is D2. So for a full wave, you can see that what happens is that if you are given this as your input, for the output, you leave the negative half, the positive half weight, right? You just flip the negative into the positive. Can you see that? You take this one up, you take this one up. So you will have only 4 positive half weight. So you just invert all half weight. Can you see that? So this is the input, this is the output for a full wave. This is the input, this is the output for the same full wave.